Hi everybody, welcome to J4K 2022. My name is Daniel and thanks for joining my session, Enter Serverless Functions Journey with the Quarkus. Let's get started. So once again, my name is Daniel O. I'm working for Red Hat as a developer advocate with a specialized cloud-native runtime, for example, Quarkus, Spring Boot, Node.js. And I also have been spending a lot of time to bring the cloud-native runtime into Serverless, Subsmash, and GitOps practice with the Kubernetes and Red Hat OpenShift cluster. I'm also responsible for CNCP ambassador. I really enjoy evangelizing a lot of developers and SRE and cloud admin to build their own cloud-native architecture and platform and systems. If you any question around my specialty or this session today, feel free to reach out to me directly with my Twitter and my YouTube channel and my Git repository. Here's my all contact information, and then feel free to follow me and subscribe me as well. Let's try to take one step back to understand how Java designed almost decades ago, like 27 years ago. Java was born to provide some kind of dynamic behaviorability and then run your Java application over the internet with multiple virtual machine, regardless of your VM app server vendors, which is really cool at the time. However, things changed that after microservice was born, and then Kubernetes and container technology were born, and then a lot of the environment for running application for immutable infrastructure, aka Kubernetes, with the Linux container technologies. So dynamic behavior does not good capability for enterprise applications and as well as developers also. So here's a good example. So for example, if you have one single microservice application with Java, then you just need to deploy in Kubernetes. So sometimes your application pod could be scaled out to 100 or even 100,000 pods in a moment. In the case, the Java dynamic behavior is not a good performance or the effective way and productive way anymore. So with the cloud application development, we need to something new framework. Or that's the big reason why developers and designers and architects are trying to optimize Java technology, but also they're looking around another program language rather than Java, such as Python, Go, and JavaScript. So today we're going to use Quarkus. I believe a lot of people already heard about what Quarkus is. The new Java framework is not brand new because Quarkus was born as almost 3.5 years ago, and a lot of people are actually join this project and make it better every single day. The Quarkus 100% open source Java framework like a Spring Boot, but this is focus more on container and Kubernetes for event-driven application and serverless functions, and then cloud native and Kubernetes native Java application. And then AKA supersonic subatomic Java with the Quarkus, which means the Quarkus allows developer make it better developer experience, but also small, tiny memory footprint and super fast startup time. So here's a quick overview of the benefit and a great feature of the Quarkus. As you can see, the 5 bullet points here. So we actually move as much as possible activity thing from runtime to build time. And also we Quarkus minimize runtime dependency and maximize dead code elimination. The more important thing for developer, Quarkus enhances a lot of developer productivity with some developer experience feature. We're going to use that kind of stuff when I showcase the demo right away. So this is actually the traditional Java framework was doing, actually is doing right now to build application, and then when you run the Java application using Java command line, this is a whole bunch of things happening underneath. First of all, when you run Java application underneath, there are some kind of stuff. For example, loading configuration and then enable, disable some features and the annotation parsing and then try to understand the descriptor, etc. In the end, the actual your application as running as the thread or process. This is a long dynamic behavior, and then this is the reason why Java feels like slow and heavyweight on container platform. So this is a new way of Quarkus. As you can see, we Quarkus shipped all kind of thing except for running process or thread, and shift from right hand to left hand. As you can see, we're gonna do that all kind of thing in the build time, and actually runtime you just run application literally. And then Quarkus actually provides two kind of option for developer. You can packaging application as job file. The Quarkus says faster, and then you can also create the executable file based on native executable running on subtrain VM. Because you don't need to have any more to JVM to run the application. This is the reason why we can call that Quarkus supersonic subatomic. With that, Quarkus 100% container strategy, specifically Kubernetes environment. So for example, container platform, which is Kubernetes, and then we have a whole same resource density working on it at this moment. In the left-hand side, you can see the traditional cloud level Java stack, which is Spring Boot, for example. And then we have a full path with the deal with some application logic. And then the second tile, you can see the Node.js almost double density of the traditional Java stack. And the right-hand side in the Go is almost 3 times density better than a traditional Java stack. And then the interesting is for importing para. And the third worker node, which is Quarkus native executable, is almost same density with the Golang. So this is totally game changer to deal with uh, the memory and then resource consumption on container technology with the Java application. Then here's a quick way how Quarkus support native executable. So everybody almost know that GraalVM, the invented by Oracle, provide some kind of SDK tool for packaging Java application as executable file. And then there are Mandrill downstream distribution project of GraalVM, which is maintained by Red Hat. It based on Oracle OpenJDK 11 and 17 as well to packaging native executable file. It also provides like a debug capability for your executable file. And then today we're gonna use more like the Quarkus funky. So everybody have some concern to deploy your Microsoft application on the multiple cloud platform, for example, AWS and Azure and Google platform, specifically serverless application. The developer always need to run SDK or API to deploy the same application to multiple serverless platform. The Quarkus fix that problem with the Quarkus funky extension, which allows developer have a portable Java API to create these functions. Once you create the function with the Quarkus funky annotation, just like a func annotation, just deploy multiple serverless platform without any code change. Quarkus funky allows developer also to have the reactive application programming. So a lot of developers actually have a big concern to change existing application as a reactive programming for event-driven application platform. However, Quarkus actually was born based on reactive engine like a Vertex and Nitty. So Quarkus Funky also provides that kind of capability at the same time. As you can see this example, you could just do still using Quarkus Func annotation on top of the method, and then you just change your return type from like an imperative, like a string or a collection to like a uni and multi, just like a Spring Boot and a mono and a flex. So with that return type, your method will be treated by reactive programming, which is really cool. And then the serverless function actually tied into event-driven application to process some of the event messaging from Kafka cluster or messaging broker or some of the other cloud provider, the S3 messaging system. Speaking of reactive application, so in order to solve that kind of learning curve to develop reactive application on the Java framework, Quarkus actually make it very simpler and then optimized framework for reactive application programming for Java developer. For example, when you try to consume or produce the event messaging between Kafka topic on your Java application, you just need to add the relevant annotation on top of the method. For example, incoming and outgoing or channel annotation, which allows your method to become reactive programming and application method. So you don't need to worry about running new learning paths to develop reactive programming. For example, as a Spring developer, you need to run something new for Spring reactive application. It's totally different anymore compared to existing Spring Boot or Spring MVC application. However, Quarkus just solved that problem just using relevant annotation and the behind the method exactly same thing just to process your JSON format data and push it into some of the in-memory data grid or store database, just like the imperative application. This is a really good benefit for Java developer to handle both imperative application but also reactive applications. And then here's another interesting part. Quarkus Funky provides the CDI injection as well as Spring DI. When you use Spring compatibility on your application, specifically serverless function implementation. So any other Quarkus application just like that. So Quarkus Funky also allows developer have a CDI injection. As you can see, we're going to use this kind of CDI injection in the live demo in a minute. And then just example, take a look at that inject annotation, which allows you have CDI injection on your function method. And also, this is the how Quarkus Funky support multiple platforms, Amazon Lambda and Google Function and Azure Function, etc. And with that, developer just to write a code like a function and a packaging application like a Maven or Gradle, the packaging tool, it automatically deploy multiple serverless platform as long as you define and enable specific extension relevant to serverless platforms. Okay, let's get right into demo how it works. First of all, this is my Quarkus project. I'm going to use Quarkus CLI to create a new project, name it enter serverless function. And then when I create this empty project, it automatically creates a bunch of the files. For example, the sample Java application code, such as hello world, and then the Maven wrapper, and then some Docker file in case you want to packaging as Docker image and then push it into Kubernetes. Let's try to open this project with the IDE tool and then go to PalmXML, just take a look at it real quick, which version you're going to use right now, and then some of the default extension automatically pulled out on my local system. For example, reactive application extension, the Quarkus is on the reactive application. You can also keep using imperative way. As you can see, there is a one RESTful API hello. Let's try to run Quarkus as a Quarkus demo, which is a great feature for developer to have live coding capability. Let me show you what live coding means right now. When you run the Quarkus demo using Quarkus CLI or Maven integrated command line, then once the Quarkus demo runs, you can see there are profile dev activated and live coding activated, which means whenever you change the code, it automatically recompile, rebuild, restart, and redeploy, which is really cool. I'm going to open a new terminal window to access the endpoint like 8080 hello, and we return hello from let's React, which is cool. My application is working right now. And I'm going to press W at the runtime, and it automatically open the welcome page, and then you can see the go to your endpoint just like with it using HTTP CLI, and also click on Visual Dev UI, which is one of the great features in the Quarkus. There are provided a config editor with the graphical way. You can find the old configuration, and also their read-only view terminal. And when you turn it on, the continuous testing, you can see the result of a unit test. This is one of the great features for developer to have a test-driven development. And we already passed one test case which already defined in a test directory. I try to access the endpoint hello and then return to hello from REST is reactive. If I change the return code in test case, just case, I'm going to change my application code like a bug fix. So let's say hello from J4K and save the file, it automatically detects that your test case failed because I just changed test case, the return code of J4K, but my actual application still return less easy reactive. So I'm going to fix the problem based on TDD strategy. Then J4K, now I'm going to just pass the my test case, which is cool. I don't even need to add some third-party tool or library to enable the test-driven development. Okay, I'm going to access the my endpoint and hello from JPK. My application totally working. In the meantime, I never ever tried to recompile, rebuild, and then redeploy as well as restart my application. Okay, so now I'm going to try to add Amazon Lambda HTTP extension, which allows me to make my application as serverless before I deploy to Amazon. So you can actually find the installable extension around the AWS. There are a bunch of the AWS extension already you can use, like the Amazon Lambda thing, and then Alexa and SES. There are so many stuff. You can easily enable the Amazon SDK on your Java application. Okay, so I just need to create a new like a CDI beans, like a greeting resource, and then I just specify application scope with this Java bean. Then create a new method such as string greeting, and then one parameter like a name. That's it. And then try to return the enter the serverless function with the Quarkus comma, and then append that name. So this is just simple serverless function CDI to return the simple context. And then I'm going to try to inject that CDI bin into my resource file, such like AutoWire in Spring Boot world. So to specify my greeting service with the injection. And then I'm going to copy existing method to create a new one. The change it to a little bit here, like a method name and then return code, as well as like a new path here. I'm going to add a new path annotation. Let's say the greeting. And then I'm going to change my the method name from hello to greeting. We did the pass down the parameter as well, the name dynamically bind to that parameter, like a name. And then I'm going to try to remove the existing text, hardcode text, and then just invoke the greeting service with the name, which is cool. Okay, I just have a file. And then let's go back to like a terminal window to invoke the same the new endpoint here. And I also needed to I don't need to produce media type because the reactive application basically you don't need to that kind of thing is already specified based on your the method type, return type. Okay, so try to access to new endpoint like a hello greeting and with my name Daniel and then enter serverless function with the Quarkus and Daniel, which is cool. Okay, so this is I just added two simple RESTful API to expose edge serverless function and Amazon Lambda. So now I'm gonna what I want to do try to packaging application as a Quarkus build. So using Quarkus CLI, Quarkus build, and I'm gonna just pass unit test to save my time. I don't have enough time to showcase all of the thing, and it takes a little bit time to packaging application like a just fast jar, like a thin jar, and then once we're done, when you go to target directory, we have a bunch of the like a outsource file, like a YAML file, and then G file is all about Amazon resources, how to deploy the application to Amazon Lambda. So first of all, this is same YAML, which is a serverless, Amazon serverless application model. So there are a bunch of stuff, so which means the developer doesn't need to run about the SDK API, how to deploy application to Amazon Lambda. So Quarkus automatically generate this kind of resources for Amazon Lambda deployment. So And then I'm gonna go to, here is my Amazon Lambda dashboard, and you go to Lambda. I don't have any Lambda function at this moment. And then I don't have any other resources around the HTTP API and gateway. So there are two ways actually for Amazon Lambda with HTTP gateway or RESTful API gateway. So I'm gonna try to use HTTP gateway. So in order to that, I just need to use the same CLI, like a same deploy using the existing this JVM YAML file. You can also using native YAML file if you wanted to deploy native executable. So let's try to JVM one, and then I'm gonna define my stack name, the Quarkus function that come from change, just no, and then I'm gonna try to press yes for allow the same CLI create a bunch of resources like a role and the SS3 bucket and also HTTP gateway and an actual Lambda, all kind of thing using same CLI. So I already configured my Azure credential on my local. So if you haven't tried to deploy Amazon Lambda on your local, you have to configure Azure credential on your local. Okay, so as you can see, there are a bunch of the resources now generated and then try to create it like a role. And then I go back to the AWS dashboard and then go to IAM, and you can see new role should be created at this moment. I already have a bunch of the role, and you can see the Quarkus function enter serverless function role just created using same CLI. And then now after that, create a new function and then HTTP gateway as well soon enough. So go back to terminal and then let's take a look at the another gateway just created and then a staging created. And then in the end, new Lambda resources also created in Amazon Lambda, which I configure from my local to Amazon cluster. Okay, it's done, and then let's go to another resource like API gateway. As you can see, so API gateway new Quarkus dash function just create it, and you can find the invoke URL which allows me access the Amazon Lambda function. And go to Lambda, and then you can see the one Lambda generated just created from same CLI. Okay, let's try to access that thing using the RESTful API like hello and greeting and my some new text like AWS production. Okay, it takes a little bit time, a few seconds, because your Amazon Lambda offers basically the core start strategy. It takes a few seconds to start the application when you inbox literally. So the inner serverless function with the Quarkus and pod. And you can also deploy a function with the native executable file because Amazon supports the GraalVM native imaging on top of the Amazon Lambda. I'm going to skip it. I don't have enough time, but don't worry. I'm going to bring that up with the existing tutorial on my YouTube channel at the end of the session. When you go to monitor menu, it will showcase a bunch of the monitor data like a matrix because during the same CLI, it automatically create a crowd formation template linked to your Amazon Lambda function. Okay, so next thing is I'm gonna remove the existing Amazon Lambda HTTP extension. Instead, I'm gonna add the Quarkus funky because I'm gonna to evolve existing this function to portable and function across serverless platform. The first thing, I don't need to get pass or any kind of stuff. I just need to do is add func annotation, which allows me make this method add function. I just delete unnecessary packaging. As you can see, my this logic pretty much simpler. And then go to resources file and application properties or YAML file. I'm gonna set it one function at once. So for example, let's try to set my function is greeting. The function name is the same name is method name by default. You can actually customize any preferred function name until the font annotation with specific name. I'm going to try to use the default name or just like a method name like a greeting. So now I'm going to try to repackaging this my application, and then it automatically generates some of the YAML file and the zip file. The one more interesting part, it actually generated a magic bash script with the Quarkus of Funky. And this is a managed script file. When you open it, there are a bunch of the Amazon AWS CLI. Means the developer don't need to remember all AWS CLI to create, delete, or update your application. So like we automatically generate, you could just hold the managed script, just like here, pass down the role, valid role name. It's pretty fast. Uh, Deploy this application from local to Amazon Lambda. Now you go to Amazon Lambda thing, then you can see the new inner serverless function Lambda just created, and then there's no API gateway, no role. So which is in the end, you can reduce resource utilization, you can reduce the cost and money to maintain your serverless function. And this is another benefit. Let's try to test the function using Amazon dashboard. At this moment, to put in the event name greeting and then text like a funky, and then just press test, and then it will show up just like a core star strategy, and it show serverless function with the Quarkus funky. So you could take the same capability, but it's pretty fast and then simpler application logic, and you can also delete that function immediately. And then if you still wanted to use Amazon HTTP thing, you can actually delete that stack using the same CLI, like same delete stack name Quarkus function. So this allows you delete all relevant resources on Amazon, like role and SSW object, and the cloud formation, and then HTTP gateway, as well as the actual Lambda function. It takes some more time. So this is a really cool thing with the Quarkus Funky to make a more advanced function with simpler logic, as well as you can deploy this application to multiple serverless platforms. So now what I want to do is deploy the same application to Kubernetes. This is a Red Hat Developer Sandbox. This is my empty project DOH dev namespace. I'm going to deploy the same function into Kubernetes because this Kubernetes already installed Knative based on OpenShift serverless feature. Actually deploy that kind of stuff. So we just delete all stack. As you can see, there's nothing in there. And back to the Kubernetes. Now I'm going to delete existing funky Amazon Lambda and then try to add a new Focus Funky Knative event extension as well as OpenShift allows me deploy this application to OpenShift / Kubernetes cluster. Like I got a target environment Knative. So one of a project make developer to manage it, build, deploy Microsoft's application as serverless on top of the Kubernetes. And then here is the image group, which is a namespace name, and a few more configuration to deploy my application to OpenShift cluster, which is a Kubernetes. Okay, so now I'm going to go back to my terminal and I try to make sure I'm already logging in the right namespace, like a DOH-dev. Then I'm going to try to build one more time, focus the build, and skip past. And then there was few more steps compared to previous build. In this case, once we packaging thin jar, and then we try to packaging application as a container. And then once you build the container image, we're going to try to push that containerized image into containerized. In this case, that containerized already exists inside OpenShift cluster, but you can also push the container image into any other external containerized, for example, like a Docker Hub or Quay.io or something. Okay, so my application actually deployed to OpenShift cluster. As you can see, the one Candy IO pod. When you go to pod logs, here's a new Quarkus version and running on JVM. You can also deploy a native executable. So just 1.5 seconds startup, which is really cool. And I'm going to change it to label on my application. to represent this is actual Quarkus application. In reality, you have a multiple application on the same namespace, which is this is a really cool feature to differentiate each application pod based on which runtime. Okay, I just copy the URL to access the application. I'm trying to hold the RESTful API like my name Daniel O and the endpoint, just like to paste that URL. Once I return, it automatically tries to trigger and it goes up your application pod, just like a serverless, and I'm gonna return an annual serverless function with a Quarkus, which is really cool. So now this is the way, and you can actually change the another label on the enable service to make this pod as a serverless function, like a boson.dev slash function true. Now you can see this is a function. So let's try to wrap up what is takeaway from this session, and I'm going to try to summarize today's session. So first of all, we learned about how to start the application development for serverless with the Quarkus, and you already run the Quarkus benefit and feature like a developer joy, like continuous testing, live coding, as well as how to enable the multiple extension and remove them once you don't need to use that. And then first of all, we just create a new just RESTful microservice application and then deploy it as a Lambda pretty easily. And then you try to optimize the existing microservices as a portable function API using Quarkus Funky, which is a cool stuff. And then we just deploy the same application without any code change, just to set it up the configuration. For example, I need to deploy this application natively rather than Amazon Lambda. And then it allows me to deploy the same application to open cluster, which is Kubernetes. In the meantime, I never ever tried to change my application code itself, but instead I just change the configuration. This is the reason why Quarkus Funky allows developer to have a portable Java API to deploy the same application to multiple serverless platforms like Amazon Lambda and Kubernetes. You can also deploy Azure Function and the Google Cloud Platform. So this is a really cool feature, making your Microsoft application bring into serverless platform. You can also optimize and evolve existing Microsoft application rather than brand new one, just like I showcased the demo. And one more last thing, as I mentioned earlier, so I already created a bunch of tutorial demo including Amazon Lambda and Google Function and Azure Function, as well as the fundamental tutorial, the Kubernetes run by example. And there are so many use cases about the Quarkus application development, how to deploy my Quarkus application on Amazon, not Lambda, just general Microsoft application, and then connect to existing Amazon cloud services, for example, DynamoDB or AWS SES, something like that. And also, there are so many use cases and solution pattern to develop cloud-native application with serverless and function and DevOps, like GitOps pipeline, so many stuff. I'm strongly encourage all of you subscribe my YouTube channel and try to give us a chance to learn something new technology whenever you have a free time. And I'm also, you are very welcome to add some comment or give me some suggestion. Hey, Dan, I need to learn something new kind of stuff like a GitOps or GitOps action with the Quarkus. Can you try to create a new tutorial video? Absolutely, yes. I'm more than happy to create a new kind of thing. Please follow my Twitter and then subscribe my YouTube channel. Give me more inspiration, which is very helpful for me in the end. So if you have any question around this session and then technical specialty around myself, don't hesitate to reach out to me directly, like a Twitter or LinkedIn or the email, even if a GitHub and a YouTube channel. I'm more than happy to address your question. Thanks again for joining my session and have a good rest of the day and enjoy the rest of J4K. Take care.